So, tried to get it from another text. Yes, it's hazy, but I have more text as well that we can get stuff from. As soon as we see the sum of, technically it would have the sum of the following arithmetic. Okay, this was actually within an arithmetic chapter, but technically you should have, because now we know we've got different, we have geometric as well. So if it didn't say for that question, you should be going, what's going on here? So we want to find the sum, and as soon as we see sum, then we're looking at these two formulas. We know that sometimes when we use these formulas, we still have to use the general term of an arithmetic, which is this. So let's see how we go with question 9. Some of you are going gung-ho on this. Some of you might be looking at this and going, I just can't remember what we did last time. And some of you were absent and didn't get to some of this stuff. So, talk to me. What's something that we could do? We want to find the sum of the first 50 multiples of 11. We've got these two formulas to play around with. Yep. Excellent. We know the first term. The first 50 multiples of 11. Now, it might be that you go, I don't even know what I'm talking about. It's 11. What's the next multiple? Plus 22, plus 33, and so on. Agreed? So, well done. From that, we now know that A is 11. Pardon? Yep. N is 50, the first 50 multiples. So, N is 50. So if we're looking at these formulas, we've got N, we've got N, we've got A, if we're going this one. So we either need the common difference or we need the last term. Do we know what the common difference is? It's 11, isn't it? Huzzah? Does that make sense? If we were just staring, and we weren't actually putting stuff on paper and we thought we'd keep it in our heads, it becomes harder than it needs to be. So we look, what information do we have? It tended to just flow. So well done. So now, to get the sum of the first 50 terms, we go S50, N over 2, so that's going to be 50 over 2. Because I've written everything down here, it's just a straight substitution, straight in. 2 times 11 plus, I'm coming to you in a minute, using the last term. Now, be careful when I'm making your questions and whatever. Sometimes I'm talking, I'm doing something else, and how many times do you think instead of going 50 take 1, I've gone 11 take 1? So that's another reason why you want to make sure that you have that. Really, I should write my formula again, but anyway. So 50 take 1, and of course, if you're saying, could I just say 49? Yes. Ooh, 49ers. It's the Super Bowl day. That wasn't the only way to do it. How else could we have done it? By using the right-hand formula.
Just times 11 by 50.
You could get the last term, excellent, by saying 50 times 11, and then you could use the right-hand side formula. So just because we go with one way on the board, Sam, did you hear what we just said? No, because you guys were talking. You could have used this formula here, because you could have got the last term by saying 50 times 11, because you've told it's the first 50 multiples. Does that make sense? Okay. Everyone happy? What'd you get? 4,000 and something? 14? 14,025. Beautiful. Okay. B. Yep. I forgot the 0 in there, right? No, can't save it. And 25. Thank you. I try and get so excited to go to the next question. Okay. The multiples of 7 between 0 and 1,000. So once again, not quite sure. We say 7 plus 14 plus 21 plus all the way up to, do I say 1,000? Has to be multiples of 7. So what's the closest multiple to 1,000 of 7? How could I work that out in a blink of an eye? You could times it. I'm not going to sit there and times. I'm just going to go 1,000 divided by 7 is Are you with me on this? 7 times point blah blah blah. So I reckon up here that would be the 142nd term. So it's up to you. You could once again go, well, I know my last term, which will be 142 times 7. I know that my A is 7. I know that N is now 142. Or you could have gone, the difference is 7 and use that. Same? So give you a minute to digest that. See what you get. I'll pop the answer up in a minute. And then chat to your neighbour about C. Okay. Shh. So have a think. We now want the integers between 1 and 100, which are not divisible. I repeat, not divisible by 3. Come up with a plan. I'd love to let you ponder for ages. What did some people do to try and get to a point? Yeah? Yeah, so we divided 100 by 3. Did you try and list the numbers that you were actually trying to add up? Wouldn't work. Now, this is the key. Not divisible. Can you do the opposite? Boys at the back, can you do the opposite? You know, like those probability questions where you worked out the opposite and took it away from the whole. Right? So, can I ask you, can you work out the sum of all the integers from 1 to 100? Yes? So you're going to work out the sum of all the integers. So you're going to work out S 100, 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way to 100, agreed? Can you work out the sum of all the numbers that are divisible by 3? Isn't that what you just sort of did for part B, but instead of doing it between 0 and 1,000 divisible by 7, you'd do it divisible by 3? And then what would you do? Minus. So once you've got all the numbers, you've worked out all the numbers that are divisible by 3, wouldn't you subtract them and you would be left with the sum of the numbers that were not divisible by 3? Have a think. I wrote that a little bit better. Oh, yeah, so N would be 33, yep. Sorry. So wrote that a little bit better. You find all the numbers from 1 to 100, add them up, and then you're going to work out the sum of the numbers that are divisible by 3, which you just did in part B, that for 7, and then subtract. So, huzzah. Now try the next one. Know how to get started? What's the go? Not sure how to start? Just want confirmation. Okay, so here we go. The 6th term of an arithmetic sequence is 21. So we're going to say T6 equals 21. Happy with that? Okay. The sum of the first 17 terms is 0. The sum of the first 17 terms is 0. Stop that sound out there, please. So S17 equals 0. find the first two terms of the sequence. So we're after T1 and T2. Agreed? So where could we start? When we've got this, what's the only thing we could use this for? What's the only bit of information we could do with this? Tn equals A plus n take 1 times d. Do we agree? So if we're popping that in, we'd get 21 equals, do we know what A is? No. N take 1, so n is 6, so I get plus 5d. We don't know where it's going, but we're just saying, well, this is all we've got. We're just going to use it. Now, when we use this one, remember we've got those two formulas. But which of the two are we going to use? We've got this, we've got this. Now, this looks a lot worse and disgusting. However, do I know n? Yes. I don't know A and I don't know D. But that means I've still got then two equations with two unknowns. If I tried going for the other formula, I'd then be sticking in a third unknown of L. So we don't want to do that. So we're going to substitute into that first one. So Sn equals n on 2, 2a plus n take 1 times d. So when we do that, we're going to get 0 equals, what's n on 2? N is our, yep, so we get 17 on 2. 2 times a, I do not know what a is, so I'm just keeping it as 2a. N take 1 times d, what did we say our n is again? It is 17, so we end up with plus 16d. Can you see that you can mess around with this a little bit? And in fact, how do I get rid of that times 17 over 2? Divide. What's 0 divided by anything? 0. So I've now got 0 equals 2a plus 16d. We've got this equation and we've got this one, and we can now solve simultaneously. We could do it by hand. If you're not in the mood, you can use your calculator. Agreed? Now, can I have everybody's attention this way? Because I just want to remind you about your calculator. Please. So, first and foremost, a reminder to you, we're going to do this simultaneous by hand in a moment, but just to remember, you go into equation, we go into simultaneous, and you pop degree 2 and you put your coefficients in, right? I'm going to ask again, can people stop talking and just listen, please? This is starting to get frustrating. I'm telling you stuff that I know, but you don't. Or maybe some of you do. The other thing that's going to crop up as you're going through and doing geometric sequences and series, you're going to have, sorry for just doodling in the middle here, but you're going to have things like, now this one we would know how to solve, but I'm just showing you that it will work on your calculator. So it might be 3 to the n take 1, right? Except it could be fractions and you have to try and solve it. Now you know that this would need to be 3 to the 4, so n would have to be 5. Do we agree? But if it's a number that you don't know, how do we do that on our graphics calculator? Who remembers? Right, we go option, calc, and then solve n. So we would go 81, your equal sign, shift above your decimal, and then we say 3 to the, now your calculator doesn't know if it's n or t or p or q, doesn't matter. This is your unknown here, your x, and we go, oh dear, I have to get out of that now, hang on. So menu, sorry, this is because I've been doing stuff with my year 12s. Type y equals. You won't have to do that because you're not playing with polar coordinates, so don't worry. Okay, x, there we go. X take 1 close your bracket. So put your little arrow key out there, close your bracket, press, yes, don't worry about that. Press exit and bang, you get 5. 5 take 1 is 4. 3 to the 4 gives you 81. So just remember where your solve n is. And that is why our calculators are great. Now we will show you how to do that in our double lesson using logarithms. Okay, but for now, go solve n. The other thing that you need to be reminded of, and please note, I'm saying reminded. You should have used this before. If you haven't, you're catching up. We might have something like, I think we just had up the back, was it 16 over 625? I don't know. Equals r to the 4. Now, how do I get r? Do we remember? How do we get rid of a 4 to the power of 4? The 4th root. So it's getting a bit squishy, and I'll write this out neater after school. But to get r by itself, 2 things that you can do. You can take the 4th root of that, or you can take all of that, 16 over 625, and you can take it to the 1/4. Both of those mean the same. That's just your index rules. Where are those things on your calculator? Well, you've got this one above the power button. Okay, if you press that, shift, and you just fill in. That's my 4th root, or my 5th root, or my 6th root, whatever you want. And of course, to the 1/4, then it's just your power button to the quarter. So be aware that's what you're going to have to use for homework when you're doing your Cambridge stuff. Finishing off, you can finish that, can't you? Solve simultaneously. Yes? Can you do it by hand? I would eliminate the A's, so I'd times this by 2, so that becomes 42 equals 2A plus 10D, and then subtract, and away I go. The A's will eliminate, I'll be left with D. Agreed? If that's too fast, then that's something you ask me about next lesson. Okay, moving along. I put 13 in here because I really liked it, because some of you would not do anything and you just stare and try and do it in your head. So if we have a look, again, the sum of the first 15 terms is 480. Make sure we read the whole thing. I'm going quick now because the bell's going to go, but don't make me stop. Rian, are you listening? Did you do this one? You got the answer?
32.
That is correct. The answer is indeed 32. But anyway, why is it 32? Find the 8th term, and we go T8 equals, don't know what's going on here. So my tip to you, because now I am sort of running out of time. Actually, no, I've got 4 minutes. I can stop and have a cup of tea. When we look at this, we go, what is going on here? We haven't got a whole lot of information. Again, with this, we have 2 formulas to choose from. Mace, did you have a go at this?
Yeah.
So which formula did you do and why?
Well, I didn't get it on.
Okay, so I would, if it was me, I'd go for the easiest formula straight away. But remember, that's got an issue with that L, the last term, which we don't know. With T8, we know that Tn is A plus N take 1D. So we're sort of restricted that we have to go with that. So we're going to go T8 equals, don't know what A is. N we know is 8, agreed. So we end up with 8 take 1 is 7D. And we go, ooh, this is not good. Not only do I not know A and I don't know D, but I also don't know T8. Don't know? Let's just do something. Never give up. Never say die. So I'm going to go with my original S15 equals N over 2, 2A. Right, I've got no other choice. I'm not going to go with the L unless this doesn't work. So we put it in, we go 480. What's N? Well, that's 15 over 2. My stomach is doing a couple of flips because I go, oh God, 15 over 2, that's not good. But I keep going. 15 take 1 is 14. Could I do anything with this? Absolutely. How about we go, how do I get rid of the times 15 over 2? Divide 15 over 2. So I get, I'm running out of room, I get 64 equals 2A plus 14D. Do you notice anything about this and this? Exactly. If I divide this by 2, don't I get that thing over there? So if I divide, notice 64, 2 and 14. These are things that we should look for, because if we can divide everything by the same number, it could be 2, it could be 3, it could be whatever, it makes our life easier. You're cancelling down. So if I divide this by 2, I get 32 equals A plus 7D. Hello? They're the same. Therefore, T8 has to equal 32. Where did I get the 64 from? How did I get rid of a times 15 over 2? So 480 divided by 15 over 2, bang. Thanks for the question. So sweet.